In this video, we're going to be taking a look at two stacked blocks, and we're going to be finding the applied force, the maximum applied force that can be exerted on the system without having our 1 kilogram block slip. So what we're going to want to do is analyze our 1 kilogram block first. We have the force of gravity. We'll go ahead and draw this off to the side. We have the force of gravity acting on the 1 kilogram block, pulling it straight down. We have the normal force from the 3 kilogram block supporting it and pushing up perpendicular. And if the red block is being pushed to the right, the orange block is going to have a tendency to slide to the left. And if it's not sliding, then the force of static friction is opposing that slide and pushing it forward. So those are all the forces for our 1 kilogram block. Now, in addition to that, we're going to want to take a look at the entire system as a whole. So we're going to take a look at all the external forces, so nothing inside of this system. Outside of it, we have the applied force still pushing it to the right. We have the force of kinetic friction as it interacts with the irregularities of the surface as it's sliding. And then we, of course, have the force of gravity of this whole 4 kilogram chunk, and then the normal force from the surface holding it upwards. So let's go ahead and sum up all the forces in the X and Y direction for both our 1 kilogram block and this large system and see what we come up with. All right, so we set up our forces in the Y and X direction for just the 1 kilogram block and the entire 4 kilogram system. So let's take a look at our 1 kilogram block first. We have Fn upwards minus Fg downwards equals 0 because there's no movement or acceleration in the vertical direction, which means if you add Fg to both sides, then Fn equals Fg, and Fg equals mg, which is mass times 9.8, and we know that the mass of the block is 1 kilogram. So 1 times 9.8 is obviously 9.8 newtons. So we know that both of these are 9.8. Now, in the x direction, we only have a single force, which is the force of static friction, which equals m times a. The mass is 1, and then the acceleration is just a. So if we plug in our coefficient of static friction times the normal force, we can actually solve this. The coefficient of static friction is 0.4, and we just found out the normal force is 9.8 newtons, equivalent to the Fg, and that equals 1 times a. So you would divide both sides by 1, which wouldn't change the value, and then your acceleration would come out to be 3.92 meters per second squared, which is going to be helpful because if that little 1 kilogram block is moving at 3.92 and it's connected to the 3, not rigidly connected, then we know that basically everything else in the system is accelerating at 3.92 meters per second squared. Now, for the sum of forces in the y direction for our big 4 kilogram system, same thing, Fn minus the Fg of the 4 kilogram system. So those two are equivalent, and which is 4 times 9.8 mg again. Both of these are 39.2. In the x direction, we have the Fa pushing it to the right, and then the FFK opposing the slide. That equals 4 times A for the entire system. So let's go ahead and clear a little bit of room so we can go ahead and solve for this Fa. So we know that the Fa minus the force of kinetic friction down here, which is mu times k times the normal force. So the coefficient of kinetic friction is 0.1. So it's basically 0.1 times 39.2 because we know that the Fn equals the Fg. So we said that was 39.2 a little bit earlier. And that equals mass times acceleration. Okay, and we did get the acceleration right over here, so that was helpful to us. From there, we can go ahead and find the product of these numbers. This is going to be 3.92 newtons, and this side is going to be 15.68 newtons. And then if you go ahead and add this to both sides, then we will have the value for Fa. And then our applied force comes out to 19.6 newtons. So in order to solve this problem, you want to make sure you analyze the block that is stacked on top and then analyze the system as a whole as well. That's probably the easiest strategy to get to the Fa. So you want to make sure you sum up the forces in the x and y direction, plug in all of your values, and then as soon as you start plugging in and solving for more and more information, that's helpful in finding your final Fa. So finding your acceleration is typically a good strategy to start off with, and then use that acceleration to plug in and then find your final applied force. So I hope that was helpful to you. Thank you for watching and listening.